Good day, folks. I'd like to show you today some simple methods that I found out just from experiment and studying and research and just playing around with this stuff over the years. Some super simple ways of making hydrogen with magnesium. So various ways, which I find is very dirt cheap and produces plenty of hydrogen for just about nothing. So first thing, I'd like to go to the basics here a little bit before I proceed here to show you some of the methods. And I'd like to start with the air-breathing oxygen cathode. The way this cathode works is very similar to the typical, we used to call the clock potato battery. But the exception is the air-breathing fuel cells. They have a great potential because they differ a little bit, from the traditional fuel cells. They take up oxygen from the ambient air or by active or passive methods, depending how you want to design this kind of a fuel cell. So this is very interesting stuff. So you need oxygen, basically, a load of salt water, which, the sea has plenty of, and some sort of a cathode which breathes in the oxygen. So to show you a simple demonstration of this concept, very simplified, not very efficient, but you can try this at home and it will work. So here it is right now to show you the simple concept of how this works. So this would be your salt water here. This would be your cathode, which is the which we're using a steel wool here, and this is very breathy, so it traps some of the oxygen and it allows for breathing. So there's your oxygen supply right there, and here's your magnesium cell, a sheet of magnesium. It could be a plate, very simple plate like this, magnesium. And what happens is, basically, you'll have about 1.5 volt here, about 100 milliamps. It's not going to be very much. It won't be efficient. But to show you that this works, you will get some power here. If you're lucky, you might get 100 milliamps. If you're really lucky, maybe around 1.5 volts DC. And it will run for about a day until the magnesium wears out completely. So, it's a concept. It's just crude, but this will work. Now we have to take it another step here, and we can make this like, hydrogen fuel cells, but air breathing instead. So what you want to do is, what we do is to make the cell more practical and smaller in size, there's various methods of working with this. So I've already showed you a tiny piece of magnesium. This is what, 25 cents of magnesium. So you make an assembly for a cell. So what would happen here is I have it here, and I'm going to show you how this all works and compare it with you and give you the different methods, and you can try this yourself. So I'm going to show you another concept here to make this more efficient. So what we do here is, when I said you have the wool cathode and the magnesium anode. Well, what happens with that is, like in my display here, they're very spaced apart and this is not efficient. So we want to squish this like a sandwich and make it into like more of a cell. So we can do that. So here's a little enclosure, for example, and here's a cage here. This would be the air breathing part, and on this side you have a carbon, and you have something a little bit extra here. What we do is we have an additional super thin layer of polymer electrolyte membrane. It's a fiber that goes in between, and this fiber enhances the reaction, and it allows us to squish. As you can see, one side has it, the other side has the carbon. But this is empty right now, so it won't do very much, right? So this is just, looks like a fancy enclosure so the air can breathe in, and you've got a carbon and you've got that polymer electrolyte membrane. And this really, the polymer isn't needed, as you can see here. It's not part of the original plan, But what happens is it greatly enhances, so we can use whatever we can, right? So what we're going to do is, you've got your magnesium plate, so you're going to want to make a base for this. So here's a base. You flip your magnesium plate in there. If I can get it there. I'm a little shaky. I got it set up so you can slide it right in there. Just because I'm trying here. Okay. Oh, I'm shaking a lot. Okay. There we go. So here's your plate of magnesium with the contact. This will be your, essentially, I guess the way we set this up, this will be the minus. Okay. So we put this in here, and this would make up for your cell here. Snap it in there. Snap. It holds in, and then you can see. But this on its own doesn't work. So what we're going to do is we're going to put in some salt water in here, and that's going to start the reaction. See, just like right here, but much smaller, more efficient. Now this is a much more efficient. This is a passive system now, and because we've enhanced it, this whole system on its own will produce 1.5 volt, 1 amp for over 24 hours. And when that ends, you will see an accumulation of a byproduct on the plate, which eventually renders it unworkable. So you open this back up, and you simply have to replace the magnesium plate, or if you want to be really cheap, you can brush off the residue, clean it up, put it back in, and you're good to go for another 24 hours. You can do that 3-4 times before the plate actually wears out. So here's your 25-cent piece of magnesium, which is set up as an air-breathing fuel cell, giving you basically, you know, close to a watt of power, or more even, for 24 hours. So as far as, you know, operating cost, you're probably getting out more work out of it than you have to put money-wise, okay? So this on its own, I understand, is not specifically the hydrogen, but bear with me. We have one more step here. You see, to find out if magnesium really is magnesium, there's an old test. The recyclers use it all the time. And you probably know what it is if you're watching this. You take a drop of vinegar, just a normal drop of vinegar, a little drop on the magnesium. You will get an instantaneous reaction. It's going to just fizz away. That's how you know it's magnesium. Now, what's interesting about this is you get a chemical reaction. What is that reaction? I had to look it up because, you know, I was interested in that, you know. What's the fizz? Well, the fizz happens to be hydrogen. And it's a super fast reaction. So, how do we enhance this? Well, very simple. Remember our cell here? We have the enclosure already. Here's the enclosure. We're putting salt water in here, right? Now you're going to make a special mixture. You're going to have to play with your mixtures a little bit, but it's going to be vinegar and salt. So there's nothing better than salt and vinegar magnesium chips. Yum, yum, yum. But the point is, non-toxic stuff from the kitchen, salt and vinegar, mix it up in the fluid, put your plate back in there. Now what you're going to get is you're going to have the normal reaction you were having before. You're going to have the 1.5 volts, 1 amp, but you're also going to have the addition of hydrogen production. Now, of course, this will eat up the plate a lot faster, so in about half a day, the plate will be disintegrated. But you get a whole whack of energy, voltage, plus a hydrogen output. So how do you... Well, it so happens I have a exhaust on here. So I put in a little pipe, a gas line basically, and this goes and feeds a hydrogen fuel cell, which converts the hydrogen output into basically a single fuel cell, which is about 1.5 volts. So if you're following me, which I'm going to show you a demonstration right after, you get this one, which is basically you turn it into a hybrid cell. It's a magnesium salt water cell, but with the addition of a bit of vinegar in there and the modification to the cell assembly, you can put a pipe on here it's a passive system. The hydrogen comes out, and if you have a passive fuel cell, it'll love this kind of hydrogen. It will convert it to DC, and you'll basically have a second cell, which is the equivalent to another 1.5 volt battery. So together, it's like having two AA batteries, right? And what's your cost? Again, that 25 cents of hydrogen, magnesium piece that you've been recycling for the last 3 days, right? So this is very small scale, but it shows you the concept. And I'm going to show you that right now. I'm going to show you the original salt water, the voltage, and then we're going to add some vinegar in there. We're going to trap the hydrogen, and we're going to bring it into a hydrogen fuel cell, and we're going to measure the output of that. And then from that point on, I'm going to show you even other ways, even simpler, to get hydrogen. So stay tuned, and we will get back to you in a moment as I set this up for you, and you can see how this all will work. Alright, so here's the fuel cell setup I was talking about earlier. This is the air-breathing saltwater magnesium cell, so we're going to start with that. So just to show you that this actually works, so here we have some regular salt, some tap water, a spare jar just to mix it up, and this spare syringe here just so we can put the solution in the cell and activate it and see what we're going to get. So here we go. I'm going to put about 20% of salt solution on here. It's conveniently marked on here. So just like that, salt from the kitchen. I'm going to put that in there. Now I've got about 5%. I'm going to want about 10 or more, and like 20 if I could. Just don't want to make a big mess. So that's close enough. Now we're going to put the salt away, and this is the regular tap water right here that I just took from the tap. I'm going to pour it in there. Right to the end here. And then we're going to shake, shake, shake. Shake, shake, shake. And conveniently over here I've got a current meter and a load box and a voltage meter, and it has a few devices like a lamp and a motor, which hopefully we'll be able to run in a moment. Alright, this seems mixed well enough. So what I'm going to do is I'm going to take a bit of this now, like that. Alright, so all we got to do next is connect our meter to the battery. There's still nothing in there, but we're just going to show you how. I'm going to plug this in here because it's not connected. So this is plus, this goes to plus over here, right over here, if I can open this one up here. Okay, and negative goes to negative, pretty simple stuff. Make sure there's no short.
right here. Here's our battery, and we turn on the current meter. We shouldn't be getting anything. 0, 0, 0, 0. Okay. So I don't know if you can see that. I'm going to show you. 0, 0, 0, 0. Okay. So now I go back to the fuel cell here, and we shall put some right here, turn a little hole, salt water in there. There's one load, and that's not quite enough, so we're going to load up again, like that. There we go. It's kind of messy, but to show you, am I lined up here? Yes, I am. Okay. There we go. That should be enough. It's about halfway now. So we will see our meter. Plug in everything here. Okay. My apologies for the slight pause. I had some corroded cables. I had to take a new clip here. So anyways, it's connected. There's water in there, salt water, and here it is. 1.39 volts. So let's carefully flip this to motor. Okay, so here it is. Here's the motor running. 0.21 amps right now. So you get more than just the salt water battery. You know, with the potato and the fruit, this is not at all the same concept, even though it's similar. So this is the air-breathing magnesium fuel cell. All I have is the cell I showed you and the meter running from the reaction of the salt water. So this will go on basically all day because it's a slow enough reaction, but I don't know if you can see it with the camera. I'll try and zoom in here if I can. And there's little see, there's a metal plate in there. We can't really see it, but yeah, eventually it accumulates and you just gotta scrub it off, the byproduct. And it's not poisonous. It's basically what's in the magnesium supplements. So, but that doesn't mean you should swallow it if you need magnesium. It's just to tell you, you know, this is not, you know, lab produced, so you don't want to eat it, but that's all it is. So, you know, non-toxic byproducts. So now the next step for this experiment is to try and get the hydrogen. So we're going to modify our salt solution and add some vinegar in here. That'll also trigger a hydrogen reaction, and we're going to pipe the gas into a additional hydrogen fuel cell to stack up our voltage. Pretty cool, huh? Okay, so here's what I'm talking about with the magnesium and the vinegar. So here it is. I've cut up some flakes in here, some little magnesium strips for the convenience of this experiment that you can try at home, by the way. So I'm going to take a piece here. This is a very vicious reaction, by the way. So I'm going to put it in here. Okay. I'm going to fill that with some vinegar. Just put a slight layer on there. look at that magnesium. Look how it fizz. If you can see that well, I'll try and zoom into it. There you see it. It's literally that, by the way. See, it's propelling itself. It's very vicious. That's hydrogen coming out of those bubbles. Yes, hydrogen. And this actually gets very hot. So with that said, it's not a good idea to use pure vinegar like that with big quantities, because we all know heat, hydrogen, boom, right? So there is actually a safety risk here, and you must be very careful. But this reaction is crazy for the tiny bit of, this is a little flake of about, 2 millimeters. I'm zoomed right in, but look at that. Just vinegar. So you dilute that with a little bit of water, slows the reaction down quite a bit, and you have a good consistent amount of hydrogen that keeps coming out for a very long time before this disintegrates. It will disintegrate, but it doesn't happen like within 1 minute. It's like within a day kind of thing. So let's try and basically utilize this. So we're going to modify our salt water magnesium cell, but instead of just having salt water, we're going to add a little bit of vinegar in there, and we're going to collect the additional hydrogen. Why not? Alright, so now it's time to get to the hydrogen stuff, which is all over here. I've got an actual setup with all the hydrogen equipment for the experiments. So now that we are going to this step, we need to find a single fuel cell for hydrogen. It's somewhere. I've got various, as you can see, lots of fun stuff in here, all related to, there's one big fuel cell which we'll use later on for another experiment. Always fun. And I'm looking for a single. It's in here somewhere. I do have one cell. Oh, I think it's here. No, that's a control board which actually measures voltage across many points and the curvature of the load, and yeah, it's pretty cool stuff which I'll get into later. But, oh, here it is. Aha. Now is this my, because one of them is actually a methanol, so I have to make sure H2 O2 fuel cell, yes. Okay, we got it right here, a single hydrogen fuel cell. As long as we feed this passively, these are the input and output, and there's oxygen and hydrogen, this will create about 1.5 volts, and you'll have some significant wattage out of it even, because it's hydrogen, it's a fuel cell, it's a technology of its own. So we're going to use this to feed the hydrogen that we're going to make from a hybrid cell. Then we're going to measure the output. Pretty cool, huh? Alright, here is our hydrogen fuel cell ready to go with the intake. And here's our original salt and water mix. What we're going to do is we're going to add some vinegar to this, like I said we would. So here we go. Getting the vinegar. And we're going to mix that with vinegar as well. As you will see. I don't want to put it all vinegar, because what happens is, you see it's a very, very vicious reaction, and we don't want to blow ourselves up here. So we got to be a little careful. We have to dilute it a little bit. Gonna mix this up real good. Gonna take a paper towel and clean up my mess here real quick. Okay, right, and get this ready. Open up the jar like that, and take a rinse. Okay, and what we will do is with the new stuff, we will fill it up. The original saltwater magnesium cell, but this time here it's gonna have the vinegar solution as well, diluted. Just gonna put them there. It's gonna take a couple of them. Okay. And just to make sure I've got enough vinegar for the experiment, I'm gonna give it a little shot, just to be sure, because I don't want to screw up this experiment. I'm gonna give it a little bit of vinegar. It's well diluted. There we go. That'll do it. Okay. Again, I must stress diluting it because this, from my own experiment, it's crazy direct. You'd want to be outside, definitely, or somewhere where there's a lot of ventilation even. So without further ado, I'm going to plug in the cell as originally. I'm going to put the plate in there, plug this in. I can, my crazy hands can get it. Here we are. Click, and as you see, the motor on the voltmeter started running right away because this is all still connected. Okay, so now we are also producing hydrogen. So I'm gonna put the pipe in here. Sorry about that, I had the wrong cap here, so I had to run and get the right cap. So I was able to put the pipe in, and we're getting a voltage rise off of the hydrogen side. It's just beginning. It takes a while for the hydrogen to saturate and get the cell going. But once it's there, usually when you have a resistance with hydrogen, it actually makes it go quicker. But for now, but this is what happens. It's hybrid, so it's doing two jobs at once, which is pretty interesting. So the hydrogen is being produced in real time in here because of the so that's pretty interesting. Okay, just reconnected the voltmeter. This is the original saltwater battery running this motor on its own voltage as the salt water does its normal reaction. This is not connected to this cell. However, this meter here is, and this is what we're getting back. So one system does not interfere with the other. So I could basically, short this right out, and it would not stop this one here. See, look, I'm going to stop it with my hand. It does nothing here because it's not the same. It's not part of the same reaction. So again, this is hybrid saltwater magnesium fuel cell. So you've got two total cells which is producing their own 1.5 volts potential individually. And they both put out about 1 amp. And again, for a very little piece of magnesium, I honestly think the cost of all this is very good for the operation. Everything you get back out of it for very little that you put in. Now next I'm going to show you something even better with the same concept. It's just I had to show you this first. But there's other ways, and it's even better than this. So stay tuned, I will show you that right now. Alright, so here's the next project, which I think is the best of them all with the magnesium. This is a fuel cell stack. It's a hydrogen fuel cell stack, so you got several of them here. And this is connected to the voltmeter, reading basically 0 because there's no gas going through. This is an accumulator I got here, and with a pipe ready to go. There's nothing in there. So what we're going to ultimately do is we are going to put some flakes of magnesium in here in the bottom. We're going to take this apart and put some flakes of magnesium and then pour the vinegar in there with the help of, you know, this. And then we're going to wash the gas, and it's going to energize the fuel cell, and I'll show you the voltage reading on this, which is the better, which I think works the best because it lasts very long and you get a lot of volts from it. So I will show you this right now. Alright, so here we go with this. First thing is to remove this here. It's a very simple piece, basically. I've done this a few times, so there's a bit of stains. And what we're going to do is the magnesium flakes, which I've pre-cut for this, and I'm going to put them in here like that. Come on. I made this one too big. That's okay. And I got another one here. I put it right here. Use everything I can. Put that in there. Here we go. So now we're going to put this in here. And we are going to load it with vinegar. So we've got some magnesium flakes on the bottom here. You don't see it, but they're there. And I'm gonna, oh, there's more, that's one, okay. That should be enough anyways. Alright, so I'm gonna put this in here. Stick the vinegar in here. Very carefully, because now I have to release the valve here because we don't have any. So I'm going to release the valve, and that's going to allow for the vinegar to go in there. Same thing. There's too much of a suction here, so I gotta make this loose here for just a moment. Just don't want to make a mess here. That's what it boils down to. There we go. So I'm getting a good quality in there now. I'd like to bring it up to about half so it can free flow. There we go. So that's going to bubble, as you can see already. That's the hydrogen. And the extra vinegar is going to go up on this chamber here. And we have the reaction going pretty strong. You can see the water fizzing, well, the vinegar, I should say. So you don't even see the magnesium, it's just the fuzz right now. But there it is in the corner, you see it, one of the flakes. So that's all hydrogen being sent out right now. So that's pushing up the tube here the gas is filling up this chamber and can exit from here, and the excess fluid forces itself up here, as you can see is already doing. You can see it working from the bubbles. See that? That's all hydrogen. So that's going into a fuel cell. So now I'm going to release the valve here to let the hydrogen gas through, because it's a free-flowing system. But it takes a moment, just like the original single cell. This is going to be a little longer because it has to basically saturate all of these one by one. So one way I can find out usually is if go here, see where there's voltage, and gives me an idea where we're going. Here it goes. As soon as there's enough gas, getting a lot of bubbly there, so it's all coming from the bottom. It'll take a while. There it goes. Six volts, not bad. You set it up right, and when I mean you gotta wait a while, it's maybe like a couple minutes, you know. I don't mean an hour here, a while. And then once it starts to get through the fuel cells, you get a quick voltage rise. So we're already at 7 volts now. And this will run all day off a few pieces of magnesium in there. So this is why I say I think this is one of the better methods. It doesn't require any electrical input to get hydrogen out. Just hit kitchen stuff, you know, vinegar and magnesium flakes. Find a way to accumulate that gas like I have and send it into a fuel cell, hydrogen fuel cell, and you're in business. So we're at 8.6 volts now. And I mean, this stuff has current. There's actually wattage behind here. I've been able to run some of the car 12 volt incandescent light bulbs off of this when it reaches close to 12 volts. There we go, 10 now. Excuse me, what I was trying to say is electrolyzer, you know. You could use this electricity for a pulse driver. There were studies about this actually, that if you pulse, not charge, but pulse the electrolyzer high voltage, it's a more efficient way of getting hydrogen out of water. So this may sound silly, but no input of energy to create hydrogen, well, electricity, there is an input. We put the magnesium and the vinegar in there. But the output they get, you know, this 10 volts here could be used for an oscillator, a high voltage. What we could do is we could use a modified flyback, a fly zapper. Take the circuit apart, it runs off 1.5 volts. So it's going to create a load. So with the load, you can you know, at 10.7, you know, yeah, that'll run it just fine actually. And then take the netting out of there, because we're not going to zap flies with it. It's got a capacitor, so it's a good pulse driver to begin with. It's high voltage. So there's the high voltage pulse, and experiment with that. I mean, I just wanted to show you, and there's many possibilities here. This is just the fundamental basics. And very little input, like I said, you know, the little 25-cent magnesium piece just keeps going and going and going, you know. And this will literally run all day. You know, this gets a little iffy, shake it a little bit, and it'll run, you know, for another few hours. But, you know, a day is actually about the max until you put more little magnesium pieces in there. It's pretty good, actually. I think this is the best out of all of the methods I've shown you folks so far. But again, it's just to show you everything that I know. And maybe someone has better ideas or can point me to better enhancements. Okay, so it took a while. Chemical reaction. Storing hydrogen. This is no electricity. I mean, this part here is no electrolysis. Then this goes to the fuel cell, which then powers the SSG motor. The back EMF going into a water electrolyzer. So this is the oxygen side. I have nothing connected to it, so the water is just dropping down. And same thing with the hydrogen side. But this was to start it with the vinegar, and then eventually run off. That's the idea from the back EMF. Alright, that pretty well sums up the experiment. I hope you liked what you saw, and it's just, you know, one of these things I wanted to share with you folks, you know, and just one of those videos that make you go, make you think, you know, maybe inspiration for something else, something maybe better. So anyways, please feel free to leave me comments if you want to comment on it. So anyhow, thanks for watching. Until next time, I'm gonna keep posting updates now and then regarding all the various experiments, and whatever I could find which seems to be interesting, I will share with you. So, bye-bye all.